Here is a soft examples about bit information. Basically, you want to work out how many bits you need to represent a particular decimal number or vice versa. Okay, the first example, what is the highest decimal number that can be represented by each of the following numbers of binary bits? So A, if we have two binary bits, so the number that can be represented will be, in general, there will be 2 to the n minus 1. So if we have 2 bits, so n is the number of binary bits. So in this case here, n is equals to 2. So we have 2 to the 2 minus 1. That will be 4 minus 1. And this 3. So the highest decimal number that can be represented in a 2-bit binary system, that will be 3. So we're going from 0, 0, 0, 1, 1, 0, 1, 1. That will be 0, 1, 2, 3. Okay, so this is the standard formula to work out what is the highest number that can be represented with an n number of bits. So B, 4. So here n is equal to 4. Therefore we have 2 to the 4 minus 1. 2 to the 4 will be 16. Minus 1, the highest decimal number will be 15, which is in a 1, 1, 1, 1 in binary. C, 8 binary bits, so n is equals to 8. So we have 2 to the 8 minus 1. So 2 to the 8 is 2, 5, 6 minus 1. That will be 2, 5, 5. D, so number of bits n is equals to 10. So 2 to the 10 minus 1. So 2 to the 10 is equals to 1024 minus 1. That will be 1023. E, 11 bits, so that will be n equals to 11. So 2 to the 11 minus 1. That will be 2048 minus 1. That will be 2047. F, so n equals to 14, so 14 bits. So you have 2 to the 14 minus 1. That will be 16384 minus 1. That will be 16383. This one, we have trying to work out how many bits are required to represent the following decimal numbers. So we have number 5. We want to work out how many bits is needed to represent the number 5. Okay, so the general formula to work out this is log 2 of the decimal number. Okay, so but this will give us fractions, so it has to be higher than that number. So we want that to be a whole number. So it has to be greater than this value here. So use capital D here. So A, we have log 2 of 5. So to calculate that using our calculator, we can change that to log 10. So this gives us 2.32. Okay, so it has to be greater than 2.3 as a whole number. So which means that I use a D here, capital D, so it has to be 3. So it means that it has to have 3 bits at least to represent the number 5. Then B, so if you take log 2 of 17, it will be log 10 of 17 divided by log 10 of 2. This gives us 4.1, meaning that the minimum bits is 5. Okay, so D, D is 5. Okay, so meaning that we need at least 5 bits to represent the decimal 17. And 25, so log 2 of 25, log 10 of 25 divided by log 10 of 2. That will be 4.6. Again, we need 5 bits minimum to represent 25. Then D is 34. So log 2 of 34. That will be 5.1. So we need minimum 6 bits. Then E for 90. So log 2 of 90. That will be 6.5. So we need minimum 7 bits. F 5650. that will be 12.5. So we need minimum 13 bits to represent 5650. Okay, so that is the soft example for about bit information.